So now that we've looked at vertical transformations, let's look at horizontal transformations, or in other words, what's happening when we move inside of our parentheses. So remember when we did vertical transformations, we talked about all of these things are happening outside. So now we're going to move inside. So for example, what if we looked at f of x minus 1? So we actually want to use our original function, which was 4x cubed minus 2x plus 2. So what happens when we put x minus 1 inside? And so this is where it gets a little bit complicated. So if we are putting it in, remember if we put in a value like 2, it means we replace all of our x's with 2. Right? But this time we're putting in an expression. So it means that expression is going to go everywhere that we had x. And so that means that f of x minus 1 is 4x minus 1 cubed minus 2x minus 1 plus 2. And so it gets a little bit weirder when we try to look at a table. So x minus 1 is actually taking the place of x. So what are we changing? We're changing x. Whereas last time we were changing y. So let's sort of look at our table. Let's put in our function. Let's put our original one in. So we'll do f of x. For x cubed minus 2x plus 2. So it's our original function. And then our new function, which is 4x minus 1 cubed minus 2x minus 1 plus 2. And so let's look at what's going on just by looking at the graph. So they look pretty much identical, except our new graph, which is our black graph, has been shifted to the right. So what we're seeing is we've shifted to the right. So let's make a table. And if we put in our original values, -3, -1, 0, 3, 5, and 8, there isn't really a discernible pattern going on here, right? -1 was 0, now it's -26. -3 was -100, now it's -246. 0 was 2, and now 0 is 0. So what's really going on here? Well, let's sort of latch onto that 0. So 0 was at -1, but has now moved to 0. And so if we've shifted right, if we changed x by taking 1 away, what if we take 1 away from all of these? What do we see? If we take 1 away, we get here. No, just want to scroll. So this is our graph. If we were to take 1 away from all of our x's, what do we see? And so we see a couple values we wanted. We see -100, and we see, that's really it, right? Oh, we see 104. That's at 4 now. But we don't see anything consistency with our original chart. So the sort of weird thing that happens is that we don't actually want to take 1 away, we actually want to add 1. So instead of -3, we want -2. Instead of -1, we want 0. Instead of 0, we want 1. We're going to add 1 to 3 to get 4. We're going to add 1 to 5 to get 6. And add 1 to 8, we get 9. And so if we do that, our chart looks exactly the same for our y's. All of our x's have been shifted 1. And so we see, we go -2, 0, 1, 4, 6, and 9. And we get the exact same values for our function that we had before. So we're seeing our x values change this time. And if you think about a number line, right? -3, -1, -2, -1, 0, 1, 2. One of our original points was -3, and it shifted to the right 1 to -2, right? That's this one. We get the same y value. Our point that was originally at -1 shifted over to 0 to give us the same y value. And so we're shifting to the right, which seems weird because we're subtracting 1, right? But if you think about it, let's think about it like zeros. If we have x minus 3 as a factor, right? Then we set that equal to 0, and we get x equal 3. If I subtract 1 from this factor, -1, then that really gives me x minus 4, right? Equals 0, and now x is 4. So by subtracting 1 inside my parentheses, I actually increase my solution by 1. So this is doing the opposite of what we might think. Instead of subtracting 1 from our x, it's actually going to add 1 from our x. And you can think of it like this. If originally it happened at 4, and we subtract 1, then we have to put 5 in to get back to 4, our original location. So it's doing the opposite. So if we subtract 1, we're actually going to move to the right, even though that's a negative number. So logically, if we add 1, right, f of x plus 1, that's going to shift to the left. So it's going to do sort of the opposite of what we might think. And so we can check this, just like we did our last one. Oops, I don't want to delete it. We can actually put this in, f of x minus 1, and see that it lines up exactly with that black graph, which means that we did our substitution correctly. So this is a great way to check your work. All right, so we're going to look at what happens if we multiply. And so I want you to take a second and think, based on our previous conversation, what do you think is going to happen when we put a 2 on the inside? Well, so let's actually look at our function. Remember that f of x is equal to 4x cubed minus 2x plus 2. So if we put a 2 on the inside, it's on the inside because it's inside of our parentheses. Then we have 2x cubed minus 2x plus 2. We could simplify this if we want, because this isn't too bad. 2 cubed is 8, x cubed is x cubed. 2 times 2 is 4 plus 2. And so this is going to give us 32x cubed minus 4x plus 2. And so we multiplied by 2 on the inside. We saw last time that multiplication was a stretch. When it was outside, though, it was vertical. Here, shifting left, right, that was a horizontal thing, right? So this is going to be a horizontal stretch, maybe? Well, let's look. So we have our original function. Let's put in our new guy. So we got 32x cubed minus 4x plus 2. So did we stretch? That doesn't look like a stretch to me, right? So something interesting to note is that our maxes and mins are about the same level that they were before. So because our max and min are about the same height, we can tell that there's been no vertical stretch or shrink. We're still the same height, but we've definitely gotten narrower, right? Like the width of our graph has changed this time. that's closer together. So it didn't actually shrink, or it didn't stretch this time, it actually shrunk. So instead of a horizontal stretch, we actually have a horizontal shrink. And so what if we put a 1/2, so a number less than 1, on the inside? So if we do f of 1/2 x, so we're going to replace all of our x's with 1/2 x. So we do this, we can simplify that. That's 4. That's going to be 1/8 x cubed minus, this is going to give us 1x. And so we're going to end up with 4/8, or 1/2 x cubed minus x plus 2. Let's put that in. Let's put that into Desmos. So we've got this guy. Let's just double check this really quickly. So let's do f of 2x. If we put that in, we can see that that is correct, what we got before. And so let's just go ahead and, for this guy, put in 1/2 x. And so when we do this, we see yet again our max and mins are about the same level. So there's no vertical stretch happening here. But we do have a stretch happening horizontally. So we've been pulled out, left, right. So this time our graph is stretching. It's gotten wider. So this time we saw a horizontal stretch. And so this is definitely opposite of we saw. A small number made our graph bigger, a large number made our graph smaller. So let's sort of talk in general about vertical and horizontal transformations. So vertical transformations happen outside. What we mean by that is that we have an a outside of our f of x, or a plus k outside our function. So we're sort of multiplying the whole function by something, or we are adding something to the whole function. Our horizontal transformations happen on the inside of those parentheses, so we're looking for things inside. So we have f of x minus h on the inside, and then we have our plus. Oh. So we have our, let's call it a b, and then we actually, that b is going to go on the outside like that, so there's sort of this multiplication is an outside or external thing in terms of where it goes. And so vertical, we're looking at up, down, and we're changing y. When we have horizontal, that's left, right, and we are changing x. So you need to think about what is changing. Are we actually changing x, or are we changing the value of our function? So when we have a times f of x, remember if a is less than 0 or negative, we have a flip over the x-axis. If the absolute value of a is greater than 1, then we have a stretch, a vertical stretch. If that absolute value is less than 1, then we have a shrink vertically. And then our outside number, if it is positive, is going to move up. And if it is negative, is going to shift down. Those are vertical shifts as well. For our horizontal transformations, that a, or let's actually call it b, on the inside, if b is less than 0, then we are going to flip over the y-axis. Think about if we have a graph, if we shift or flip left, right, we're flipping over the y-axis. If the absolute value of b is greater than 1, if it's a big number, then we're actually going to see a shrink. This is a horizontal shrink. If that number is less than 1, we're going to see a stretch. This number on the inside, so if we see a positive number, so if we have x plus 4, for example, right? If we see a plus sign, then that's actually going to move us to the left. If we see a minus sign, then that's going to be a right shift. So something to remember is that this kind of does the opposite of what we think. Whenever we're on the inside, these horizontal transformations are always opposite.